The stream is live with Play-In Lost by Scourge. Adverts are starting.
Welcome, Swarm, to the stream where pixels flicker and the chat will beat. Though you fluttered off, your presence remains. In whispers of wings and echoes of games.
A swarm of dead insects, okay. Here's what I'm sending to chat: ambient music. It's fine. Good for background noise, I guess. Not exactly going to get anyone hyped up, though. Welcome back, a swarm of dead insects. You're welcome for the adverts.
She's got her own throne, buzzing keyboards, wires go. Welcome to my jingles, let's start the show. Click, 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 she's ready to strike.
Welcome back, Chloe.
Streams, cutie like raccoon power, shining bright, second tunes. All through the night, sound
It only does that when you're not there, Chloe. Hello, how you doing? Oh, hello, Chloe. Hello, Swarm. Hello, lurkers in the corner over there. Oh. Right. Carrying on with yesterday. I don't know how I sound today, because my audio system has all been reconfigured. Hey, Switchgear, how you doing? You have a fun bit of silly small tech. Excellent. We like silly and small. We especially like silly, especially if it's tech. USB-C PD to MagSafe 2 adapter. Oh, knife.
Switchgear.
Nice, very nice. What was I saying? I can't remember. Carrying on with what we were doing yesterday, yes. My audio, yes. I've reinstalled the operating system on my 2009 MacBook Pro. Ancient thing. Core 2 Duo, 4GB of RAM, and I've shoehorned, what's it called on there? I never know what these bloody OS X releases are called. One of the many that begin with an M. Monterey. I've shoehorned Monterey onto it. Just about. But in doing so, I had to reinstall the control software for my audio mixer, and in doing so, it wiped all the settings on the audio mixer. Nice. So I've had to reconfigure them all, and I don't know if I've got them right, so I don't know how I sound. OCLP, yes, that's the one. And I'm sure I just heard myself briefly in my headphones then for some reason. Maybe not. Maybe I'm just hearing things. So yes, I OCLP'd it. I would love to be able to OCLP this baby, but it's too old. This is a... hang on, am I hearing myself? I shouldn't be. Let me just check my settings. That should be muted. That is muted. No, maybe I'm not. It's a little... it's a Mac Mini 2.1, I think, or something. It's a year older or 2 years older than the... It's going to be either 2007 or 2008, I think. It's a Core 2 Duo, but I think it's only a 32-bit, not a 64-bit. So trying to get anything 64-bit on it, you're screwed. It won't even boot the patcher at all. It's Core 2 Duo. I've actually upgraded the CPU in this to the best one that it can run on, and it still can't even boot the booter. So yeah, no chance. Right, but as far as I know, I sound okay, do I? I'm not clipping too much or too quiet or anything. Yeah, you've got to have the whir, and the bong. You've got to have on an Apple. Anything that's not whir, and bong is just not a proper Apple. So if I'm sounding okay, then I shall shut this down to save the battery. Also because it's in my way. And put it to bed. I'm trying to upgrade the MFM emulator for the mini vac. I'm just trying to get it to do anything, really. I'm not upgrading it. The purpose of this is to... I'm definitely hearing myself. Why am I hearing myself? Just like a distant echo every now and then. Something weird's going on. It's only very faint, just really in the distance. I don't know. I can live with it. It's such a faint sound. Right, yes, the purpose of this really is for the BDP11. This is to go in. It's my clone. Wait, you've said too much. I don't have a clone. The minivac has been upgraded to Blue SCSI, the VAC Station 2000. that I know of. What have you been doing, Chloe? So the VacStation 2000 is blue scuzzed now and all working happily. And this is for the PDP-11, which is not working happily because it has no hard drive. So I guess today is to start trying to see what we can get in the way of life out of it for programming, if anything. After doing the bodges yesterday, I mean, we know that it functions, but can we actually program it to do anything useful? Hey, Hot Rocks. You had a choice, clone the streamer or clone the bot, and well, there was no contest.
Hot rocks.
But the bot wasn't available, so you cloned me instead. Right, yeah, I guess we're going to be programming, aren't we? So I'm going to need a programming environment of some form. Let's stick that one over there where I can see it. That one can go there, and that's where we'll program. Actually, I'll pull that down to that corner. OBS can go up in that corner. And we'll program over here. There we go. Can you imagine the bot in stereo? Never be in sync, would sound like an SEC product. Ha ha ha. Well, that's a good start for a start, isn't it? I can't type at all. So this has changed now, this format, because I want 19 bits of address, 8 bits of current data value, 3 bits of head, 2 bits of pin data, which is 19, 27, 30, 32 bits. So all bar the last 2 bits get shifted straight out again, and the last 2 bits get replaced by read-in data. CD Git, you're already a Git. Proper programming environment smells of warm electronics, is filled with a hum of fans and includes incredible quantities of Thai black coffee. Well, there's quite a few fans around. There's lots of warm electronics in here. I'm out of coffee at the moment. I don't even have tea at the moment. I could go to get some, really. But I do have Vim, if that's of any interest. Right. So I'm going to need, I can't remember how to do PIO stuff. Right, this is a PIO program that makes a pin blink. We'll call it data stream, this. Program data stream. Hey, G-Pen.
Welcome back. Jeepin 247.
Okay, so what's the sequence that we were doing? We want to pull block, is it? Then it's out pins 2, out ISR 30, in pins 2, push, no block. Now the program to compile this is PIO ASM. So input and output. And it doesn't work. Well, you don't want side set turned on. Okay, so that has created data stream, which is a C file, isn't it? Or is it a header? That's a header file, actually, isn't it? Okay, so this is our set of instructions. 5 instructions: pull, out, out, in, push. That's the structure to define it. That's the configuration function. That's the initialization function. That calls that, doesn't it? Yeah. Stop making you want bacon. Bacon. Bacon is the king of meats. Let's just put this into the make file. And for this, I need that. So that should then call that when needed. Right, so that compiles at any rate, not that it does anything. And no such thing as pork, there's only bacon cooked in various forms, actually. Absolutely. Right, so where were we with this? This is what we do to get it going. Let's just... Okay, then in setup, we do that, and that still compiles, does it? That still compiles, right. Let's install it. We might have a PIO program running, not actually doing anything. So I need to configure the FIFOs actually now, don't I? For this, really, I'm going to need the SDK manual, aren't I? And there's probably all sorts of fancy ways of doing this all wrapped in things now, isn't there? But no, that's not what I'm looking for. Pico SDK.
Seems the chat is having a documentary about the king of meats. Then might need to start cooking to settle the debate.
That's what I'm looking for.
Advertisements are now playing.
That's the ADC FIFO, not the ADC FIFO. Talk of the devil.
Welcome back, man. Hope you're cooking something good tonight.
Right. Or is it in the configuration stuff?
Thanks for enduring those headlines.
I don't need side step set. So the config, PIOSM config. Set out pin base, set in pin base. SM config out pin base. Output is based at no. Output is where. SM config shackles on the wall, that sort of thing. Yep, Absolutely. Right, so reading and writing, data is 12 and 13. So output pin base will be 12. And the in pin base will be a 0, as that is write data and write gate. Right, what else do we need to do? I mean, I've got it running quite slowly at the moment with a massive clock divisor. The hidden hook in the ceiling was a current fad. What do I need? I need to set up the FIFO, don't I? Set out pin count, set in pin count, I suppose, isn't there? These need to be pointers. I don't know why they weren't. There we go, that compiles. Right, so we've set the pins up. We're not doing sets, we don't need to set the set pin base. We're not using side set. And maybe the FIFOs are just doing what they're doing unless you tell it otherwise, like joining them. Because you can actually join the two FIFOs. You've got the send and the receive FIFO. You can actually join together into one bigger send one or one bigger receive one if you don't need the other one. But I think probably by default it's just split and running and don't actually need to do anything. There's one function to do both of those, set out pins. So I can actually do set out pins to 12,2, set in pins 0,2. Actually, the set in pins just has a base. This is strange. You've got set out pin base, which takes the base, set out pin count, which sets the count, and set out pins, which takes the base and the count. The same for the set. Takes the base, count takes the count, and the pins takes both. Then for the in, you've got the base, set in pin base, takes the base, set in pin count, takes the count, but set in pins just takes the base, apparently. Which is weird. Is that a typo? Or was that intentional? That is not a typo, that is intentional. Now maybe the count is just completely ignored. Ah, set in shift, set out shift. This is where we set up the shift register, the FIFOs. SM config set in shift. We could do auto push, which might save. Auto push and auto pull, which might save a bit. But no, I'll do it manually for now. So shift right. Not sure. I think we want shift right, don't we? Auto push, false. Push threshold, doesn't matter if we're not doing auto push. SM config set out shift. I think we want to shift left on this one. We don't want to join the FIFOs. SM config set FIFO join. That has values of that there, PIO FIFO join none. Okay, special functions we're not caring about. Set mov status. Set source for move status in a state machine configuration. I'm not using that. Trying to debate the idea of making gravy. It's not hard. Gravy granules in jug, water in jug, stir, done. I'm definitely getting some echo of myself through my headphones here, and I don't know why. Is it being picked up by one of these other microphones maybe and feeding through in some way? No, it can't be. No. Why can I hear myself? It's annoying me now. It's only when I speak loudly I can just get this faint echo of myself. Large Yorkshire pudding, mash and sausages. Whoa! You've got to have gravy then, yes.
Majenko, I think you should check your microphone. It seems to have died.
It's quite right, it had died. Cook water off till it struggles to pour. Sounds good to me, yes. I'm not familiar with hendos, to be honest. Could be a northern thing that hasn't made it this far south yet. Non-Yorkshire thing, absolutely. It's a northern thing. It's from Sheffield. Okay, so now I need to remember how we send stuff through the FIFO. For that, I think I shall... Let me just check this compiles. Let's have a look. This is calling the TXF for the state machine that we're using. TXF and the RXF within the PIO. Okay, so we go PIO RXF SM let's have a short delay and then PIO TXF. Hang on, this is no, it's other way around, isn't it? That hopefully should be feeding stuff through the state machine now. If we're lucky. Okay, why did it not find it? Okay, let's do a manual reset. Your Pico is now a brick. You're welcome. Well, we've got data. Not the same data. Bricks this small. Right, let's try something else then. Let's add another one here. And see what happens. What really bugs me with these pipe ecos is they haven't bothered to put a reset button on them. Now it's a brick. Won't communicate at all. Ah, there we go. Right, so we're getting data going through. It's wrong data, but we're getting data. It's alternating predictably, which means that what we're getting out is being affected by what we're pushing in. So, what are we doing? We should be just shifting data. Let's, out of interest, just try a straight through stream.
Adverts are now playing.
Come on. There we go. Ah, right. It is feeding through, but our shifting was breaking it.
Thanks for enduring the tech news.
Right, so the fact that we were doing out pins 2 and then only shifting 30. Is it the ordering that is getting messed up? It could well be. Let's try changing this to false false. Hey Sleepy, how you doing? We've got data going through our FIFOs. But that's all. It's getting corrupted. Right. So I'm sending it in hexadecimal. 1, 2, 3, 4, 5, 6, 7, 8. Four, 8, D, 1, 9, E, 0. I've lost an 8 there. Right, so that's the output left shifted 2. Okay. So we're shifting left twice more than we need to, or? Or do we need to change the order of these so it does that? It still talks, you fail to see this is better. Right. So we're now feeding the data through with the 2 bits at the end just being cleared at the moment. So in theory, if I were to get a wire of some form, and some glasses so I can see what the hell I'm doing. And connect 3.3 volts on here to that pin on there. No, where was it? Where's my schematic? Data out is pin 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is that pin there. Touch that to there. Nothing changes. To get on ground, nothing changes. Okay, let's try the one next to it, which is... Oh, that's data out, sorry. No, that's wrong. It's these ones up here I need to be trying with. Nothing there. Nothing there. That should be right data that I'm connected to. And it's not picking it up. Schematic is now the gas oven from a grand day out. Yeah, I think it might be. Cracking cheese grommet. Hey, Dopaz. Let's try doing something different here. Of sending all zeros. Come on, replace, will you? And then all Fs. not sure if you found a unicorn or you're messed up somewhere, but you found that TI-99 for a DC power board that has a 5-pin male connector only uses 4 of the pins, 3 a gap and 4. Ah. Like a form of keying, is it? No, I'm not getting any change at all on these pins. Is there something I'm not doing that I need to do? Oh, hello.
It seems chat is having a relevant
Set consecutive pin DIRs.
regional delicacies.
No. SM PI no, go up here actually. Set consecutive pin DIRs, PIO SM. PIO SM set consecutive pin DIRs. What's the format of this silly one? Base count is out. So PIO state machine base count, yeah, base is 0, count is 2, is out is true. And the input ones, no, is out is false here. And these are 12 to true. Right. Your beige box TI-99 4A expects a 4-pin connector. Ah. Right, can I get this to change its value? Can I buggery? Ooh, hang on. PIO GPIO init. That's not going to work, is it? Oops. Set up the function to select for a GPIO to use the output from the given PIO instance. I don't use these parameters. Actually, offset I do use. Nope, still no change that. Okay, I wonder if there's anything happening on the output pins. Oh, I know what I need to do. I need to turn power onto my shelf, don't I? Shelf is that button there. Okay, oscilloscope is booting. Oscilloscope has booted. Okay. See if we get anything on here. Aha, output is working. But not input. Right. Let's try that format of the configuration. Aha! We have input. We have input values. Haha, right. What was wrong was using the equivalent of smconfig set out pins for the input pins. It just doesn't work. Because it doesn't take the count. It can't work out what the hell it's got to do. So you've got to split it into pin base and pin count. You can't use the one that's supposed to combine them two, but just doesn't seem to actually exist. So that is working. Now let's get it going at full speed instead of horrendously slowed down for the blink sketch. And if we turn this back on, reconnect it. I should now see it rising and falling faster. No. It's still... I don't know. There's still a good big long delay there between sending into the FIFO and it rising. Big long delays are the best delays. No, they're not. Not when you need to be going at 20 megahertz, it's not. Set clock divider 0. Let's try 1 in case it just doesn't like 0. Briefly back. Better than not being back at all. Have you managed to find enough kitchen to do your stream tonight?
Advertisements are now playing.
I think actually the delay that I'm seeing is OBS. Because if I try and look at that and the screen at the same time, I can't. But yeah, there's about a half-second delay in what I'm seeing on the screen there compared to what I'm seeing up there. So there is no delay. It's just OBS being OBS. You've just finished moving your study desk and cleaning up the cable and crap nest that was lurking behind it. Well done. Well, you got an hour and a half to clear some kitchen space.
Thanks for enduring the thought.
Right, so no, wrong file. That file, please. Right, so one, two, three, four, five, six, seven. There's 8 there, isn't there? We'll add a /r and a /n as well. Make it 10. Right, so that's our test data. Thanks for enduring the bot. Yeah. My day was pretty good, actually. I've spent it upgrading my networking. I'm now pretty much completely 10 gig where it matters, i.e. between 3 computers. And I'm getting almost 10 gig as well. Look at that, 9.4 gigabits per second. No, I'm not using Unify. I'm just using some dual port RJ45 10 gig Intel cards using direct interconnects. Yes, I've got basically three computers here. I've got my main workstation, which has got a dual port card in it. I've got my backup and media server, which has got a dual port card in it, and I've got the NVIDIA Jetson, which has got a single port in it. It's also got a 4-port 1 gig, which is sort of like my main local switch as well. So I've then got a direct connection between my workstation and my backup server at 10 gig. I've got a direct connection between my workstation and the Jetson at 10 gig. I have no idea, Tyler, I have no idea. And then I've got a 1 gig connection between the backup server and the Jetson. So it's all three are basically connected in a triangle with a whole loop, and spanning tree sorts it out. I've set the priorities and link costs to be just right, so that if my main workstation is on, traffic between the Jetson and the backup server goes through the 10 gig links via my workstation. If my workstation is off, it just goes down the 1 gig link. Yeah, but that costs money. This is free. All this costs is just cards, and you need the cards anyway. Unless it's only 3 computers, you don't really need a switch. In fact, I have switches, but I don't really use them much. I've got one up here on my desk for connecting stuff to when I'm working out on my desk. And I've got my big switch down in my stack of kit down there, which I use for other things, like linking up down there and things like that. But for the main networking, I don't have a switch. My computers are the switches. If my main workstation's off, there's a funny smell. I didn't have the cards. I bought the cards cheap on eBay for about 30 quid each. 2 cards is all it took. But you can't use a switch if you haven't got the cards, so you've got to buy the cards anyway. So yeah, but that's $300 I don't have. Whereas I've got plenty of cables. Click, set up a bridge in software, bam, there's your switch. Each computer is its own switch. I've got a 3-port switch, a 3-port switch, a 5-port switch, all linked together basically, and each one is also a computer. So if I go, actually I can turn that off now, can't I get that out of the way? So I've got 3 network ports, and I've got a bridge that I call SW01. There's 2 active ports at the moment, both forwarding. Bridge, link, show, master, SW01. This is on George. It's got a lot of things on that bridge. Let's pipe that through grep, space EN. That's just the Ethernet's 5 ports, one of which is blocking because it's not needed. So it turns it off to stop the loop. So that's basically a 5-port switch. Well, more ports because it's got all the virtual stuff inside as well. The internet link is on George. George is on all the time. George is guaranteed to always be there. But George actually has 2 links to the internet. It's got a Wi-Fi link, and it's got a an Ethernet link. Which is actually a USB Ethernet connection, that one there. So it's got belt and braces. George is the Jetson. Yep, George Jetson. George is the bot's brain. So I can get at my backup stuff and my media really quickly, which is nice. Oops, I just closed that. I didn't want to close that. Brain in quotes, yes. Right, what was I doing? Gosh, dang it, yeah. Okay, so I've got a bit of test data here. And for I is 0, I is less than 10, I plus plus. PIO TXF was it? Equals test data I. But that's not what we want. What we want is struct. I'll call it squirt. So we have I remember the format of this. Address data I can't remember the format of this. I think it's like that. Been a while. ARF. Let's get it right.
Welcome back, RF programmer. Hope you're ready to dance.
No. That might be it. Oops, that needs to be a 1 there. So S address is I. S data equals test data I. S head equals 0. S dot pin 0 equals I equals 0 for the index. And S pin 1 equals test data I and 1 left shift S head. And we're sending make this a union along with value. Might work, might not. Spin 1 equals whee! PIO RXF SM hex. See what we get back in. Probably won't compile. It did. Okay. I am surprised it compiled. I think I managed to save your ears then. I hope I managed to save your ears then. What have we got here? Complete and utter gibberish, haven't we? You heard nothing, but you had your head in the oven. No, it's not that bad, Ben, is it? Let's go s.value equals PIO RXF SM. Actually, let's add a delay in here. Let's add a dump function. Right, see what is going on now. He hasn't been to the complaints department of SCC, he'll be sticking his head in a pig. Nice. Right. This is all backwards, I think. Or is it? No. Actually, no, it could well be backwards, yes, because this is going to be affected by I've got my ends wrong, my endianness wrong. This needs all swapping around. I thought I might share and enjoy. Okay, address 0011223344567890. On
Ben's culinary adventures are inspiring some interesting ad placement lately.
So address 0, this pin here is going 1. That's the index pulse. On all the other addresses it's 0. On this pin here it changes its value depending on the lowest bit of this value here. So a 5 is a 1, a C is a 0, an F is a 1, 2 is a 0. That's working. D is a 1, A is a 0, that's correct. So I don't need to dump anymore because I know that the format is correct. So what I shall do now is data, now if S pin 0, no, pin 1, isn't it? I'm doing. Actually, these are.
You're welcome for the tech news.
Pin 1 is. Yeah, it should be pin 0, I think, for that. Is it pin 0? Data is 13 in. Yeah, pin 1. These are named wrong, aren't they, I think? But pin 1 is the right one to be doing, and they're in the wrong order here, of course. But that's irrelevant. Right, so pin 1 is the correct one for the data to be on. So if S pin 1, no, not if S pin 1. If S pin 0 is 0, if we are asking it to write, then if S pin 1 S data or equals S head left shifted, no, or equals 1 left shifted by the head value, else S data and equals the inverse of 1 left shifted by the head value. Right, so now we should see Hellold coming up. With corruption because it thinks it's writing. So the write enable is that one there. Let's bring that high. Or is it that one? No. Oh, there we go. Get that right. So Hellold, that's writing not enabled. Writing enabled, and it corrupts it all with it changes the data. Writing disabled, writing enabled, writing disabled, enabled, disabled, enabled. Excellent. We are getting data back in, kind of, in a way. How can I wait for the FIFO? Data goes in, guts come out. That's what the Majenko industrial concern is all about. Because without adding my own little delay in there, I think I'm reading gibberish from the FIFO. Or am I? Maybe I'm not. Let's just disable writing for a moment. Okay. No, I'm not reading gibberish. I'm reading hello old. So it does block on the reading of the FIFO. That's okay then. Okay, so let's add a little one up here for... Let's have head of 2 this time. And actually I'm going to add a little delay in here. Just so we can see it, what we're doing. Ice cream, good-o. Head was not declared. Didn't tell it what it was. Well, I didn't need to reboot it manually that time. Okay. I think that's Klingon, isn't it? It's all offset by a byte, of course, isn't it, as it goes through the FIFO. So if S address is 0, then we'll print a new line. Reboot manually kicks the bot. That's rebot manually. Rebot pedally. That failed that time. Let's reboot. It's flashing. Balspakaku. Balls to you. The 12 debugging axe. Nice boots. Kinky boots. Come on. Work, damn it. Come on. Thank you. Stupid pie. So that's reading data in from outside with a 0 being fed into bit 2. And that's it with a 1 being fed into bit 2. Let's take the constant away from this bit. And then I can go test data s address equals s data. So we're now storing the data. test data. That's what the bot creates. Okay, so that has now corrupted my data internally. If I go to set that high, that's still giving that data. If I set that to low and then fill that bit with ones, it stays there. We have a 10-bit single head hard drive. A 10-bit hard drive. That's progress. I don't know how fast it's going. Going at ludicrous speed at the moment, hopefully, although it's slowed down by the outputting of the text to serial. But the proof of concept is there. It's actually feeding data through. More memory than you have. Oh, it's all the time you spent with your head in the oven. It's fried your brain. Actually, that can go inside there. I only need to modify it if we're writing. So that's a basic hard drive. Five haircuts. Fine if you don't want to have a shave as well. Right, so what's next? What time is it? I've got another hour yet until Ben is supposedly ready. We can officially store one ASCII character, yeah. Actually, I'm going to have this run at full speed because we're not outputting anything now. And we'll have a look at the output from it on the oscilloscope. And that, I think, is our index pulse. That looks like an index pulse to me. And we are running at 410 kilohertz. which is maybe a little on the slow side. Let's set the clock divider to be 0. And it's gone incredibly slow.
Advertisements are now playing.
No. That looks more like data, actually. We've got the right pin. Was I seeing the wrong data before?
Thanks for enduring the ads, everyone.
That's the pin we were looking at originally. That's the one next to it that way. That's the one next to it that way. Index should be pin 16, which is GPIO 12. It should be that one. Unless that is the index, and it's just so erratic. Why so erratic? And then the data should be coming out. Oh, the data will be corrupted, won't it? Data should be coming out on 17, which is that one. If I touch that pin to 3.3. No. Not seeing anything. Maybe it just doesn't like having a clock divider of 0. Because this should be the index on this pin. And that's with a clock divider of 1. That's 410 kilohertz, which is effectively, because there's 10 bits being sent in that space, that's effectively about 4 megahertz, 4 mega samples per second, sorry, which is a fifth of what we need. Division by 0 on your clock is an exciting new innovation, yeah. There's 2 clock dividers, if I remember rightly. Set clock divider, oh, it's a float. Set the current clock divider for a state machine as a float value, they've got it as these days. Ah, that's the one I was thinking of, FRAC 8, which gives you an integer and a fractional portion. That's a floating point divisor. Let's try 0.9, see what that does. If that breaks everything. Probably does. Yeah, that's broken. So I can't have less than 1, which is logical if it is an actual division. Yeah, a lot of the time the Raspberry Pi doesn't identify properly as a mass storage device. You can't see that behind the what's it there, can you? A lot of the time it just doesn't identify properly. Or it tries to identify and then says, screw you, not talking. So we need to run the whole system about 5 times faster. Okay. We're currently running at 125 megahertz. It's got 300 in the options here. I'm not sure how we set these.
It seems Majenko bot is now a potential target for overclocking and manual reboots, hopefully. It's got some good safety boots on.
That option, build FCPU. Build property. No. Board options, menu ID equals option ID. And it is Freak 300. Okay, let's see if we can melt it now. Freak 300. Let's melt the chip. Now that'd be 2600, wouldn't it, Chloe? Right, we're now running at 800 kilohertz. We're getting there. That's about 8 megahertz. We need slightly more than double. So we're going to need to run it at around 800 megahertz. We're heading towards a gigahertz. it might need cooling. Not sure this is actually going to be a viable system, the way that I've got it set up. It is indeed PC Magus. What we're looking at on the scope here at the moment are the index pulses for a 10-byte track.
Wow.
So 10-bit track. Just 10 bits, and those are the index pulses, and they're going at about 800 kilohertz, which means that each bit is approximately 8 megahertz, about 8 megabits per second, and it needs to be 20, and we're already overclocking like buggery. So yeah. I don't know where all the slowdown is coming from. Let's turn on auto pull and auto push. That doesn't seem any quicker at all. Auto pushing has not made any difference. Right. So if this is running at 300 megahertz, then that's going to be, if it's 1 clock for the loop, we've got 1, 2, 3, 4, 5, 6. So that's going to be 50, that should be running 50 million times per second. So for a PIO program reading its own output, the changed output value becomes visible as an input 4 cycles later. 2 cycles later if synchronizers are disabled, fair enough. So I've taken out all the logic around it at the moment and just outputting the pulses. And that's got it up to 1.7 megahertz, which is about 17 megahertz all told per bit. We're getting there with no logic. if we don't bother reading the FIFO,
Advertisements are now playing.
then it's just the same speed.
With 69 bits, Swolfted Insect says.
Cheer 69. No logic, brain empty.
Thank you for the bits. No logic, brain empty. Absolutely. That sums the bot up, really, doesn't it? Well done, Ben. But you have food. You had plums, but you've sat on them. Right. Not sure what the best
During the ads, everyone.
thing to do is with this now. It's going to take some thought. Because I get the feeling that the slowdown is probably coming from the outside, feeding the data into the FIFOs. But with that cut down as much as possible, we're still we're still 300 kilohertz away from our target. Took your brain off though last night. Oh. I mean, I could do it without the try doing it without the PIO and just bit banging it in software. That way everything is completely synchronous and I don't need to care about addresses and heads and things like that. And I could write it in assembly language. I'm not familiar with ARM assembly, unfortunately. I'm more of a MIPS assembler, me. Well, you can get RISC-V versions of the Pi. So, RISC-V is an option. But RISC-V is almost identical to MIPS. So yeah, I can do RISC-V. MIPS I can't. It's ARM I can't do. I have a RISC-V version sitting on my desk right now. It can do both. It's got both cores. It has 2 ARM cores and 2 RISC-V cores. Oh, does it? You can enable any 2. The RISC-V ones aren't faster than the ARMs, are they? What are the specs on the RISC-Vs? ARM Cortex M33 processor. And then the Hazard 3 processor. High performance RISC-V processor with 3-stage pipeline. There is option. Set the Arch to RISC-V. Arch RISC-V. No hyphen. This might be compiling it to run on RISC-V core now. And manually reboot it. Give him to Tony. Oh, come on. Reboot properly, will you? Thank you. Ooh, the RISC-V is faster. RISC-V wins. With zero logic, we are running at our target of 20 mega samples per second when overclocked at 300 megahertz. Haha, RISC-V wins. I always knew RISC-V would win. ARM's crap. ARM processors are utter rubbish. I've never liked ARM processors. Give me MIPS any day and MIPS derivatives any day. It's supposed to be slower? Well, on here it's running faster. Now this is the Raspberry Pi. Raspberry Pi Pico 2 has 4 cores in it. 2 ARM and 2 Hazard 3, which is RISC-V or RISC-V. You can enable one or the other, either the ARM or the RISC. ARM is slow compared to the RISC for doing this specific operations. And I could program it directly in assembly, yes. You could have one of each. Weird. But we are running at 2.09433 megahertz on the index pulses. 2.09432. Unless there are 10 bits in that space, that's 20 megabits per second. You think you're going to bop me over the head with the top case with RPC? No, I hope not. Just because I'm dissing ARM. I'm very much a MIPS fanboy. Always have been. Not really, GPen. Not really, because we're running as fast as we can, and we're just reaching our target speed, but we're not actually doing anything with the data. If I enable the code to actually load the data and save it afterwards if required, then we'll drop right down in speed again. Had to make a call, so you're MIA, fair enough. Yep, we're now back down to our 700 kilohertz. Now that we're actually testing the data and uploading it and all that sort of thing. Need a more efficient way to handle this in code. It should be more than fast enough. I'm wondering if there is another way we can do it. Neither doing it in code nor doing it with PIO. But instead using SPI to do it. Either SPI or I2S to do it, possibly. Make use of where are we? We got I2S? No I2S, but there is SPI. Yeah, basically, because that gives you an input and an output. On the 80 meg PIC32 parts, it can happily run at up to 20 megahertz. It's got FIFOs for stuffing the data through. Can be driven from DMA. Programmable data size 4 to 16 bits. And we can't get other things like index and the right gate through it. Shouldn't be a problem for index. Index doesn't have to be synchronized with any specific place so long as it's predictable. But the right gate is important. And there's also QSPI, which are the 4 data pins. But those are used for the flash chip on board, so that's not usable. I was thinking I2S would be better, because then you've got things like the left-right clock and things like that that could be utilised. But it doesn't exist. It doesn't have I2S. I'm going to have to think about this. It might just be a case of just bit banging it in assembly language as the way to go with it. It has I2C, but I2C is strange. It's also quite slow. The chip hasn't got particularly warm anyway with all that overclocking, so we could probably clock it further if we can work out how. But SPI, you get 1 output, 1 input and a chip select. QSPI is currently in use to talk to the flash chip on the board. It cannot be used. Plus that's only half duplex. You get receive data, you get transmit data, you get clock. And you get various interrupts and things. What does it tell us? Yeah, you get the serial clock, you get the transmit data, receive data, and an active low chip select.
And chip combination.
I'm wondering actually if I could run it in slave mode. Run it in slave mode with the chip select as the right gate in some way. But that probably wouldn't
Advertisements are now
then allow it to work, would it? because it'll only be active when chip select is low. How to wait when not selected? Absolutely, yes. There is only one SPI peripheral, isn't there? Or is there more than one? 2 SPI controllers. Ooh.
Thanks for enduring the ads, everyone.
Could I run 2 SPI controllers synchronized together? One with data going in and out of it, and one with control signals going in and out of it, index and right gate. I've still got to generate the actual data though. But if I'm always working in a stream, then the head is not going to be a bit within a byte, it's just going to be an offset in the data stream. Yeah, they'd have the same clock. I shouldn't need to do anything fancy to increase the frequency, because SPI can run bloody quickly. Yes, an ISA bus runs at, well, no more than about 8 megahertz. 4 megahertz on an old XT class machine. And is transaction based, with the ability to have wait states and things like that. This isn't. This is like audio sampling, but at very high frequency. I'm going to have to mull this over, I think. Ben, are you ready for streaming yet? Do you fancy starting a few minutes early? Have you managed to find enough kitchen work surface? Enough table? Afraid not. Oh, bugger. I'm just going to have to sit here and waffle for a bit then. We've got some progress anyway. Proof that it could possibly work if we can go fast enough. But we may have to rethink how we're actually going to squirt the data. Okay, you go take a dump. Make faces at the camera for a bit. If we can have... Let's just have a think. If I'm using SPI and I'm switching heads, if I'm limiting the head switching only to the beginning of a track, So you can't switch heads partway through a track. I don't know if that ever happens, or whether it'll always then wait for the next index pulse to come around before it starts reading. If that's the case, then I can switch heads at the beginning of a track, and the actual sending out of the data would just be squirting using DMA direct from memory straight out through SPI. But then I'd also have to be sucking back into memory through SPI using DMA into another buffer. Let's have a think. So if we've got 20,000 samples per second, 20 million samples per second, and it's 3,600 RPM. So, no, let's do it in decimals, shall we? So 3,600 RPM is that many seconds, about 2.75 milliseconds per revolution. The data rate is 10 megabits per second. So no, hang on. Ten megabits per second, and we're running for 2 milliseconds. That's not right, is it? Oh, sorry, that's 3,600 RPM, which is that number of, that's number of seconds per revolution. Right, that's that number of bits per track. That's that number of bits per sampled per track, which is that number of bytes per track, with however many heads we want. And then 2 buffers, a reading and a writing. It would fit, but then we need 2 buffers and it won't fit. We need 2 sets of buffers, one for data, one for control stuff. This is getting complicated. I don't know. I need to sleep on this. Definitely need to sleep. My best ideas come to me when I'm asleep. It might be a case of just manually bit banging it in assembly. Just about to bounce and fire up OBS, but first... ... You're keeping me hanging, aren't you? There is no busy. There's nothing really to say I'm busy changing heads. No, there's a seek complete, which it asserts after it's got to the next track, but there's nothing for the heads. I think there is a ready, but that just means that the driver is available and can be selected or has been selected. I think it's sort of the inverse of select, of drive select or something. It's not used as a busy flag. All right, go set yourself up. We'll come and join you momentarily. Come on, press go live. Press go live, come on. Where are you? Come on. Press go live. Oh, you've got to find it all in amongst all your tabs first. Come on, Twitch. Come on, Ben, hurry up. Hey, Mock, just in time for the raid. Just in time for raiding Ben. Hey, he's now live.
Welcome back, okay heroes.
Part 8 of the LA50. Right, I guess we go raid. Thank you for joining me this evening. We've got some head scratchers now to think about. I'll come up with a solution, I'm sure. And I'll see you all tomorrow. Raid time!